Schrödinger's cat. This is honestly one of the most bizarre and famous thought experiments in the history of science. It's a paradox that, well, really challenges our understanding of reality and showcases the strange rules of quantum physics. But what exactly is Schrödinger's cat? How does it work? And what does it reveal about the quantum world? Welcome to Großdenken, my friends. In this video, we'll break it all down in simple terms and take you into the weird and mind-bending world of quantum mechanics. But before we begin, let me ask you to support this channel by just subscribing. That would mean a great help. The story begins in 1935 with Austrian physicist Erwin Schrödinger. Schrödinger was one of the leading minds behind quantum mechanics, but he had some concerns about how quantum theory was being interpreted. At the time, a popular idea called the Copenhagen interpretation suggested that particles, like electrons, don't exist in a definite state until they're observed. Instead, they exist in a superposition, a combination of all possible states. Schrödinger thought this idea was strange, so he came up with a thought experiment to highlight the weirdness of quantum mechanics. This hypothetical experiment involved a cat, a box, and a very unusual setup. Here's how Schrödinger's thought experiment works. Imagine a sealed box. Inside the box there's a cat, a vial of poison, a radioactive atom, and a Geiger counter, a device that detects radiation. The radioactive atom is unstable, meaning it has a 50% chance of decaying and a 50% chance of not decaying within a given time. If the atom decays, the Geiger counter detects the radiation, which triggers a mechanism that breaks the vial of poison, killing the cat. If the atom doesn't decay, the vial stays intact and the cat remains alive. So until you open the box and check, the cat is in a quantum superposition. It's both alive and dead at the same time. The instant you open the box and observe the cat, the superposition collapses into one definite state. The cat is either alive or dead. Schrödinger didn't mean for this thought experiment to be taken literally. He wasn't suggesting we should put cats in boxes. Instead, he used it to show how strange the rules of quantum mechanics are when applied to the macroscopic world, the world we experience every day. In the quantum realm, particles like electrons can exist in superpositions. For example, an electron can be in two places at once or spin in two directions simultaneously. But Schrödinger's cat raises an important question. Can quantum rules, like superposition, apply to large objects like cats? Or does something change when we move from the microscopic to the macroscopic world? Schrödinger's thought experiment also highlights the role of observation in quantum mechanics. According to the Copenhagen interpretation, a quantum system remains in superposition until it's observed. Once observed, the system collapses into one definite state. For example, before you open the box, the cat is both alive and dead. That's superposition. But when you open the box, you observe the cat, and the quantum state collapses into either alive or dead. This idea, honestly, has led to countless debates among physicists. What does it really mean to observe something? Is it the act of a human looking at the system, or, well, does any interaction count as an observation? Schrödinger's cat also inspired alternative interpretations of quantum mechanics, such as the many-worlds interpretation. According to this theory, the universe splits into multiple parallel realities whenever a quantum decision is made. In the case of Schrödinger's cat, in one universe, the cat is alive. In another universe, the cat is dead. Both outcomes exist, but in separate parallel worlds. While this idea is fascinating, it's still highly speculative and not universally accepted in the scientific community. So, can Schrödinger's cat happen in real life? In the quantum realm, yes. Scientists have observed superpositions in particles like electrons and photons. For example, an electron can be in two places at once. A photon can act as both a wave and a particle. However, when it comes to larger objects like cats, quantum effects seem to disappear. This is due to decoherence, a process where interactions with the environment cause quantum systems to lose their superposition and behave more classically. In other words, the quantum weirdness of superposition doesn't scale up to the macroscopic world, at least not in ways we can currently observe. Schrödinger's cat remains important because it illustrates the mysteries and challenges of quantum physics. This thought experiment has paved the way for groundbreaking research, including quantum computing. Quantum computers rely on superposition and entanglement to perform calculations that classical computers can't handle. Quantum cryptography, quantum principles are being used to create secure communication systems. And fundamental physics, Schrödinger's cat continues to inspire experiments that test the boundaries of quantum mechanics, helping us better understand the nature of reality. Even though it's just a thought experiment, Schrödinger's cat has become a symbol of the strangeness and potential of quantum physics. Schrödinger's cat is more than a paradox. It's a window into the bizarre world of quantum mechanics. It forces us to question how reality works at its most fundamental level. While we may not yet fully understand the quantum world, one thing is clear. The rules of physics at the microscopic scale are far stranger than we ever imagined. What do you think about Schrödinger's cat? Does it confuse you, or does it make you even more curious about the universe? Let me know in the comments below. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more videos about quantum physics, the mysteries of the universe, and everything in between. Until next time, stay curious.